Hi guys, it's Kevin here, and today I'll be showing you two sum. This is the first question on Leetcode, and it's a easy problem, or marked as easy. It's has some nuances that are probably very new to beginners at programming, and yeah, let's just get started. So, what is the goal of two sum? So, given an array of integers called nums and a integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, so there is a guaranteed solution. And you may not use the same element twice. You can return the answer in any order. So they give us a couple examples. This is the first example. So as you can see here, you have a target, which is 9. This is the number you want to sum up to. And you're given this list of numbers, of integers, 2, 7, 11, and 15, called nums. And for clarity, I wrote out value and index. So indexes start at 0, so 0, 1, 2, 3. So since 2 plus 7 equals 9, which is our target value, these are the correct values for the solution. And just as a reminder, the goal is to return indices, so not the actual values that sum up to the target, but the index, so where they are in this list. In this case, 2 is in the 0 index and 7 is in the first index. So the answer actually wants us to return 0 and 1. This is the second example with 6. Same thing, values of 3, 2, and 4, index 0, 1, 2. So obviously 2 plus 4 equals 6, so these are the index values that are the solution, so 1 and 2. So they give us one last example. This one's, only 2 long. So since 3 plus 3 equals 6, these values are correct, and you return the indexes of 0 and 1. Alright, so how would we go about solving this using programming? So from intuition, you could just, add up all the existing pairs, right? And see if they equal the target value. So if it does, then you return the current index location, which is starting at 0 and then you go up, and the found index. So you start at 0 and then you check 1, 0 and 1. So 2 plus 7 is 9. That's correct. So we return that immediately. In this case, we don't get the answer right away. So 3 plus 2 is 5, not 6. So we move on to the next one. So 3 plus 4 is 7. And then you get 2 plus 4 equals 6. And you get the answers of 1 and 2 for the locations. Now, checking every single number in the array with another value from the array, this array doesn't have to be 3 or even 4 numbers long, right? It can be any number long. Like you could have an array with 1,000,000 numbers. And if you think about that, trying to find the solution for that is like you take the first number and then you check 999,999 other numbers with that number. And for large sets of numbers, this takes a lot of time, like even for computers. So is there a better way to do this? We can use something called a dictionary or a hashmap. So this is a data structure that is able to store key value pairs. for example, this dictionary right here, it stores John into the value of name, 19 into the value of age, male into the value of gender. So how can we use this key value pair to help us solve the problem of two-sum? Alright, so going back to the first example, I made 2 additional rows here. This is our dictionary. This is our data structure where we can store numbers and variables and other sorts of things like that. So what we're going to do is we start with an empty dictionary. So as you can see here, there's no numbers. And now instead of checking to see if the first number plus the second number equals the target, we check the first number. So here is 2. And we subtract 2, or whatever number this is, from the target to get a value. That is the value we want, right? So 9 minus 2 equals 7. And then we check if that value exists in the dictionary. And since we started with an empty dictionary, for the very first value, we're never gonna have it. So we don't have the value, so let's see what we can store. So we can actually store a key value pair of 0 and 2. So based on that, we now have this entry of the value of 2, and also we have the value of the index where 2 is stored. Because this is the given input, 2, 7, 11, 15, right? But we don't actually have these index numbers right here are not seen by the code, right? So we're iterating through this list one at a time, but we don't have the variables to store the values. But now with this hash map, we can actually access it and store additional values and actually relate them to the indexes so we don't lose them. So just continuing with the example. So the next number is 7. Now if you take the target and you subtract 7, you get 2. And if you check the dictionary, 2 exists. So we know that the 2 from a previous number, it doesn't have to be the first index or the 0th index, but we know that it already exists, and that is the exactly one solution that we found. So this 2 plus 7 is the solution. So now we just need to access the indexes. So this index is accessible because this is the current index we are checking. So we always have track of this one. And this is accessed from the dictionary. So let's do this again with the second example. So we have 3 and 0. And 6 minus 3 is 3. 3 does not exist in the dictionary, so we add it. Or we add the original value. And then we do the same thing for 2. So 6 minus 2 is 4. The only value is 3 here. And move on. And now 4. 6 minus 4 is 2. So we have it. We have our solution, which is 1 and 2. Or 2 and 1. The order does not matter. So why is this better? Well, if you check every single number in the array from before, right? It's a very time-consuming kind of algorithm. So we call that O of n squared, because you're basically comparing the same array with itself. So n times n minus 1, and that simplifies out to generally n squared. But using a dictionary, we can actually check if the number exists in the dictionary in constant time or one time. And we can also add information into the dictionary, a key value pair, in constant time. So this, when using a dictionary, you only have to iterate through the list one time instead of having a double loop. However, there's always a trade-off in this sort of thing. So we are using more memory because we're storing values into a data structure, into variables, when originally we don't store anything at all. And there's pretty much almost no memory use. So you can see here, the left one is the intuition approach, and the right one is the dictionary approach. And this is the code in Python. And you can see here, the runtime is significantly faster, while the memory is very different. So the brute force approach uses almost no memory, and it beats 94.45% of other solutions or submissions. And on the right, because we're using a Hashmap / dictionary, we have about 13 to 14%, like we're in the bottom 14%. But in the real world, we usually optimize more so for space complexity, because CPUs are generally fast enough to handle even badly coded algorithm, but memory is a bottleneck that is seen in the real world and real application. So that affects the actual program more than the time complexity does. Leetcode problems tend to overcompensate on the time complexity in terms of importance.